everyone, and welcome to the second part of our little fractions crash course for algebra students. Today, in this video, we're going to look at equations that have fractions, and I'll show you two methods of doing each type of problem. Now, the first method that I will show you in each equation is that of a more traditional way. We're just going to keep the fraction and work with it. Second method that I'll show you for each problem, we're going to get rid of the fraction first and foremost, and then continue on solving. Let's get started. So method 1, traditional way of solving, we're going to just look at it like a normal equation and begin by adding 12. So we have 18 equals 3/5 x. And the step we take in this method to cancel out the fraction is multiply both sides by a reciprocal, which is our fraction, flipped upside down. In this case, everything cancels by the x. We're left with just 1x. And then we multiply on the left-hand side, 30. Now let's take a look at the method where we cancel out the fraction. Sometimes it's a longer method, but it does feel a little safer, so I'm a fan of it. Now what we're going to do here is get rid of the fraction by looking at the denominator. Our denominator here is 5, so I'm going to multiply every single part of my equation by 5. It is going to make my equation 5 times bigger. However, these 5's cancel. We no longer have fractions to worry about. All right, so we have 30 equals 3x minus 60. And now we have a regular two-step equation. I don't know if you guys heard a loud noise just now. I did. I hope it didn't record it. And if it did, I'm so sorry if I scared you, because I jumped in my seat a little bit. Okay, let's divide by 3, and we get the same exact answer. The method you choose is purely up to you. I do not have a favorite, and I've been doing math for a long time. I think they're both great methods, and if you plan on going further on in mathematics, you'll see that you kind of pick and choose which method is best for you in certain situations. Let's move on to example number 2. Similar, but it does have a negative with the fraction, so I want to emphasize that part. Once again, let's do method 1 traditionally. Method 2 will get rid of the fractions. Okay, so let's begin by subtracting. Okay, so we have negative 16 equals negative 4/3 x. I don't like how that x looked. There we go. Once again, I'm going to multiply both sides by the reciprocal. What gets tricky here is making sure to bring along the negative. The reason being, yes, the 4 and the 3 cancel, but the negatives must cancel too. So on this side, we have x, negative 3/4 times negative 16 gives us a positive 12 as an answer. Okay, so that's the first method. Let's look at the second method, which will get rid of our fraction. This time we have a denominator of 3. So we're going to multiply every part of our equation by 3. Okay, so 24, negative 4x, 72. Looks like a regular two-step equation. Let's solve that. 24 minus 72. I think it's negative 48, but let me double check. I don't know, I'm having a little brain fart. Doo-dee-doo-dee-doo. It is negative 48. Shouldn't doubt myself. Okay, we finished this problem by dividing by negative 4, and 12 is our answer. Two different methods, same answer, matter of preference. Okay, so the two problems we just went over only had one fraction in it. Let's take a look at some problems that have more than one fraction in it. So here's this one. It looks a little intimidating, and I totally copied and pasted it without the negative, so I am going to include that. Okay. So let's do method 1 traditionally. I need to write down that negative in front of those 2/3 like I had in my problem originally. Okay. All right. So if we're doing this traditional method, we are going to have to create common denominators. Now I know that I can turn 3 into 18 by multiplying it by 6, and I can turn 2 into 18 by multiplying it by 9. All right, so now we have negative 12 over 18 plus 27 over 18 equals 73 over 18. Okay. Treating it like a regular two-step, so I'm going to subtract 27 over 18. So we have that negative 12 over 18 x equals 46 over 18. Yes, 46. And then I'm going to finish by multiplying both sides by that reciprocal, negative 18 over 12. Okay. On the left-hand side this time, everything cancels out. On the right-hand side, the 18s cancel, so that's pretty nice. I can also reduce 46 and 12. I'm going to reduce them both by 2. So 23, 6. So x equals 23 over 6, which we can rewrite as 3 and 5/6. All right, let's do the second method. In this method, we'll get rid of the fraction. Okay? So it will look, you're going to recognize some numbers in here. It's going to look similar to method 1, except we won't have those 18ths. Whoops. Oh, I lost my negative on this one. It should be negative 23 over 6. Negative 3 and 5/6. Okay. Now, I'm going to once again use my knowledge of the multiplication table. And what I know is that I can make 3 into 18 and 2 into 18. So their common denominator is 18. So what I'm going to do is multiply every single fraction by 18. That looks like a 7. There we go, 18. Let's multiply. Let's start with the left. 18 and 3 cancels out into a 1. 18 becomes 6. 2 and 18 cancel. 2 becomes a 1. 18 becomes a 9. And these 18s cancel out completely. Okay. So we have negative 12x plus 27 equals 73. I got 12 and 27 by multiplying 6 by 2 and 9 by 3, those numbers that we have in red. Okay, two-step equation. Doesn't look intimidating at all anymore. Subtract 27, negative 12x equals 46. Then we divide by negative 12. So we get that x equals negative 46 over 12, which reduces into negative 23 over 6, which can be rewritten as negative 3 and 5/6. There it is, guys, dudes, friends. very similar. If you take a look at method 1 and 2, you should see the 12, the 27, the 73. We're doing a lot of the same stuff, except we're just not involving the fraction in method 2. On to the fourth example. Okay, this one's a little different. There's several ways we can do this. Let's do it a more traditional way and then get rid of the fractions way. As if that's not how we've been doing it. All right, let's get it going. First thing I'm going to do in the traditional method is get rid of the fraction by multiplying both sides by its reciprocal. Okay, on this side everything cancels, and I'm just left with x minus 2. And on the right hand side I have negative 15 over 2. I finish this problem by adding 2 to both sides, and I get that x equals, well, negative 15ths is negative 7.5, and if I add 2 to it, we should get negative 5.5. Okay, I know that's a decimal. I don't know why I said and a half and then wrote a 0.5. That was bizarre. Okay, let's continue. Method 2, we're going to get the same answer, but we're going to get rid of just the denominator first. So I'm going to multiply everything by 5. So on this side, cancel, cancel. We have 2 times x minus 2 equals negative 15. Then I can go ahead and divide by the 2. And we're pretty much at the same step. All right, so not that different of a method here. The second method has an extra step to it, but if that is a method that you want to just keep doing, get rid of the fraction, that's the way you would do most of your problems. Keep doing it that way so you don't confuse yourself. All right, example 5. Okay, more than one fraction once again. Let's check this bad boy out. All right, let's do it the traditional way. Traditional way states we must create a common denominator. Well, everything is 15ths. Recall that 2 is actually 2 over 1. So let's make everything into 15ths. So I'm multiplying my 3 by 5 and by 1 by 15. All right, so I got 10 15ths plus 30 over 15 x equals negative 86 over 15. Okay, let's subtract 10 15ths. Okay, we have 30 over 15 x equals negative 96 over 15. That does not look like a 15. Let's try that again. And then we multiply both sides by 15 over 30 to get rid of that fraction. Right, let's see. Cancel, 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 cancel. Awesome. X equals. All right, in this one, 15s cancel. And we can actually reduce 96 and 30 by 3. So I'm dividing both by 3. Oh, you know what? I can take this even further. I can reduce the 32 and the 10 by 2. So I guess I could have reduced it by 6, but it is what it is. So what am I reducing by? Oh, by 2. So then we have 16. Okay. Don't always know that you can reduce right away by 6, but 16 over 5, which would be 3 1/5. I lost my negative again. It should be negative. There. Oh. There we go. That's kind of a negative, right? Let's use this tiny eraser to make it look nicer. There we go. Alright, so there's that method. Now, let's take a look at method number 2. In method number 2, we're going to get rid of the denominators right away. So I see that I have a 3 and a 15. And you know what? I can multiply, I can get 3 to become 15. 3 and 15 will cancel. So what I'm going to do is multiply every single part by 15. Because I know that will cause the denominators to cancel. I knew it would cause it on the right-hand side because the bottom is 15. On the left-hand side, 3 and 15 reduce. Okay, 5 times 2, that's 10, plus 30x equals negative 86. Subtract 10, subtract 10. 30x equals negative 96. And we divide by 30. X equals negative 96 over 30, which I found out we can reduce by 6. I don't know. Oh, yeah, that's why I wrote 16. Okay. Negative 16 over 5, which is negative 3 1/5. I had a brain fart again. My apologies. So that method seemed a little faster again. There was a difference there. Any method you like, you do that one. Okay, 2 more examples. Oh my, look at all these mixed numbers that we're going to turn into fractions. A, S, A, P. I'm just going to do them for both versions right away. Negative 11 halves equals, we multiply and then add 6, 1, negative 7 thirds plus 19 sixths. Okay. All right. I'm going to start this off with method 1. Once again, we're going to find a common denominator. Now, if you look at the denominators we have, the 2, the 3, and the 6, whoopsie daisies, we can turn the 2 and the 3 into a 6 by multiplying the 2 by 3, the 2 by 3, and the 3 by 2. Okay. Trying to scroll down a little bit. Okay. So we have negative 33 over 6 equals negative 14 over 6 plus 19 over 6x. I'll begin by adding 14 sixths. All right, negative 33 sixths plus 14 sixths gives us negative 19 sixths. I don't know why I did that so ugly. We're going to try that again. Negative 19 over 6 And that equals positive 19 over 6. Multiply both sides by reciprocal. On the right-hand side, cancel, 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 cancel. On the left-hand side, cancel, 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 cancel. We're just left with the negative sign. So we're really left with the negative 1. Whoa, I didn't know I could do that. I just learned something by accident. Okay. See, that happens. Learning can happen any day. So, there's our traditional way. Let's do it the second method, where we'll get rid of the denominators. Up we scroll, up we scroll. All right, so I see a 2, a 3, and a 6 in the denominator. I know that 2 and 3 are both divisible by 6. 6 is divisible by 2 and 3, so that means we can cancel the denominators, by multiplying everything by 6. Let's do that. Okay. So when we do the 6 and the 2, 2 becomes 1, 6 becomes 3. The 3 and the 6, 1, that becomes 2. Those cancel. Gorgeous. So we're left with negative 33, because 3 times negative 11. Negative 7 times 2 is negative 14, plus 19x. I add 14 to both sides. So we get, we just did that. Negative 19 equals 19x. We divide both sides by 19. And we get negative 1 equals x. Now, in problems like this, you should maybe notice, or maybe not, but method 2 is a lot cleaner. So when there's a ton of fractions, I like to get rid of the denominators. But, sometimes you have teachers that will prefer you to do it one way or another. That was my situation, so I got good at both methods. And when I got to college and continued on doing math, I got to pick which one I liked better. Okay, here's our last example of this very long video. Stay strong if you made it this far. What we're going to do is solve it. Surprise! At least I can make myself laugh. All right, traditional method. Let's get rid of that 5/7 in front of the fractions. I'm trying to zoom in even more, so the bigger my handwriting is, I think the little bit clearer it is. All right. So what I'm going to do first here is multiply both sides by 7 over 5. That cancels out one fraction right away, which is nice. Let's see if we can reduce anything on the right-hand side. All right. So let's begin with the 145. Is 145 divisible by 84 or 5? Well, I don't have to know if it's divisible by 84 because I definitely know it's divisible by 5. And I know that because it ends in a 5. Anything that ends with a 5 is divisible by 5. 5 times 49, 49? What? 29. 29 gives us 145. Well, hopefully 84 and 7 will cancel. You might know that already. It does. 7 times 12 is 84. Fantastic. Let's see what we have left. 3 halves plus x equals 29 over 12. That's much nicer than 84s and 145s. I'm going to create a common denominator for 3 halves and 29 twelfths by multiplying 3 halves by 6. So we have 18 over 12 plus x equals 29 over 12. And we're going to finish this problem by subtracting 18 over 12 from both sides. Alright, so let's see how many twelfths we have. 29 twelfths minus 18 twelfths. We are left with 11 twelfths. Okay, not bad actually. This one wasn't too bad. Let's do it the other method. We're going to try and get rid of all the fractions. Now what I'm going to do first in this method is get rid of the parentheses by distributing so we can see what our fractions are, and then get rid of the denominators. Okay, so I have 15 fourteenths plus 5/7 x. Alright, let's see if we can multiply them all by a certain number. I know that 84 is divisible by 7, because 7 times 12 is 84. But is 84 divisible by 14? Yeah. 14 times 6 is 84. That means I can multiply everything by 84. By 84 in order to get rid of my denominators. Alright, let's see what we get. 14 times 6 is 84. 7 times 12 is 84. 84 times 1 is 84, so those cancel. Okay, let's check out our new equation. Our new equation is going to be 15 times 6 is 90 plus 60x equals 145. I'm going to multiply 15 times 6 on my calculator to make sure I did it right. I did. Why am I like this? So much self-doubt. Alright, let's subtract 90 from both sides. So we have 60x equals 55. And we finish by dividing by 60. Let's see if we can reduce this. We can. I can divide both the top and bottom by 5. X is 11 twelfths. You'll get there once I write it. There we go. Perfect. Okay, I hope that this was helpful for you when you go forth into the world of math and solve some equations with fractions in it. I hope I gave you lots of options. If you have questions, comment down below. Sorry for the loud noises you may have heard during this video. Good luck in math. I'm here for you if you need me.